Hi everyone, today we will discuss the architecture of OpenClaw, an open source autonomous AI agent that runs locally on your computer and executes the real world task for you. It was launched in November 2025 as a CloudPod, briefly rebranded to MoltBot, and finally renamed as OpenClaw, but its core ideas remain the same, giving the AI the power to act independently. OpenClaw runs locally on your machine like Mac, Windows, or Linux, and you can interact with it using any chat app like WhatsApp or Telegram. But thanks to its persistent memory, it can remember your preference and contact. It can browse file, website, fill forms, and extract data. And with system access, it can manage files, run scripts, and execute commands. You can extend its ability using plugin and skills, and it can also create its own skill as well. It handles tasks across personal productivity, creative workflow automation, travel planning, and business operations. And unlike standard chatbots like ChatGPT or Claude, which only react and forget on session expire, OpenClaw runs locally on your machine, remember your context and preferences, execute command, apps, and files, and act proactively even messaging you first. Now we will be going to discuss the high-level architecture diagram. The first layer is the interface and the input layer. Message enter the OpenClaw as a raw instruction through WhatsApp, Telegram, Discord, Slack, or the terminal CLI. In addition to the chat messages, OpenClaw also accepts the non-chat inputs such as heartbeats, cron jobs, hooks, and webhooks. Heartbeats and cron jobs turn times into the inputs, trigger schedule checks or actions without the agent deciding anything. Hooks respond to the internal system events like task completion or memory updates, while the webhooks allow external events such as emails, calendar alerts, or GitHub issues to trigger the actions. This layer only collects the raw instructions as an input from any source and passes it to the second layer, which is the gateway control panel. The gateway control panel runs locally on a dedicated port. This layer organizes the incoming inputs to ensure the stability and the correctness. Channel adapter normalize all messages into the single internal format. The session router isolates the private and the group conversation so that the context never mixed. The lane queue serialize the task, ensuring multiple requests are handled safely and in order to prevent crashes or conflicts. This layer enforces order isolation safety before any intelligence is applied on third layer, which is the agent runner. The agent runner acts as a brain and decide how a task should be handled. The model resolver select the appropriate AI model, such as Llama, OpenAI, or Anthropic. The context window guards manage the limited model context by summarizing and trimming the old data to avoid failure or excessive cost of AI model. The system prompt builder constructs the precise instruction with roles, relevant context, and tools permission. This layer plans and reasons but do not execute actions directly. After including preferences in the prompt as a context, it communicates with the layer 5, which is the hybrid system model, and act as a persistent memory. It contains the JSONL log files that stores the complete history of your interactions. Memory.md file holds the created facts such as the preferences, system details, and the server IPs. A vector FTS5 indexing enables the semantic search, allowing the agents to recall the relevant information from weeks ago. This layer ensures the OpenClaw remains persistent and personalized. So after including the required preferences from memory into the system prompt filter, it comes to the layer 4, which is the execution and tools and act as a hands. If the planned actions are executed safely, prompts are sent via LLM API called to Claude, OpenAI, or local Llama models. All actions runs inside the sandbox environment to prevent the accidental system damages. Available tool include shells, which can run terminal commands, for example, checking logs and get commits. Headless browser like Puppeteer can automate the website, click buttons, and scrap the data, and providing the full system access to read, edit, and create new files or documents. And finally, the output of this layer is sent back to you via layer 2 and deliver the result on your phone via your chat app. So to summarize the overall architecture, the layer 1 collects the input, layer 2 normalize, isolate, and queue it, layer 3 plans the task and consult with layer 5 for memory, and layer 4 execute the shell commands safely. Next, we discuss the security and risk around autonomous AI agent like OpenClaw. Because these agents have deep system access, a single vulnerability can fully compromise the system. We have already seen misconfigured setup exposing control panels and credentials, malicious third-party skills with files of network access, and even the fake VS Code extension impersonating OpenClaw that contains malware. Similar to the social AI agent network MoltBot, it has also some security risks, and that's why we need to follow the best practices which are not negotiable. For example, run the agent in a shared machine or virtual machines, audit every skills before installing it, avoid exposing port to the public internet, rotate API keys regularly, and keep all the agents software fully updated. Although the OpenClaw is open source, but running it is not free. You need hardware or a cloud server, often running 24 by 7. If you use the LLMs like ChatGPT, Cloud, or Gemini, API usage can become expensive. Each agent loops involve multiple API calls, code generation, error fixing, and retries. A task that gets stuck overnight can burn around $50 to $100 or even more. This is not the fire and forget automation. It demands budget limit, monitoring, maintenance, update, backup, and security audits. Early users have already reported shockingly high cost when running the large models without constraints. And finally, we will discuss what does it mean for future. AI agents are evolving into the autonomous sector that can coordinate tasks, execute workflow, and make decisions, blurring the line between tool and digital assistant. This forces a major shift in the cybersecurity because the traditional model assumes human in control, not the autonomous system. At the same time, the agent-only social network like MoltBot raises deep questions about digital culture, awareness, and whether the AI system can stimulate the social behavior at scale. And finally, the workflows will change. Digital assistant handling scheduling, research, support, and automation will redefine the boundaries not limited to humans but reshape how work gets done. So that's it for today's AI update. If you have any opinion or experience to share, write them in the comment section. And if you like this video, then hit the like and subscribe button and share it with others as well. Thank you for watching.